not learning if you don't know why. Because guess what? That's memorization, which is fine. Memorization should happen naturally after you understand why. But if you do it before understanding why, then you forget, and then you have no idea how to re-remember it, right? Until somebody tells you, hey, you got to do it this way, which isn't really learning. Think about it. I know. I throw fractions at you and lose your freaking minds, right? 2/3. Think about what that means. We're going to add a half. Think about what 3/5 means. Baker. Thank you. Why? Sure, that's how it works out. Like, it works out nicely that way, and you get a nice answer, right? But, like, why can't we just do that way? You're right, but that's not quite what I'm getting at. I don't think it applies. What is a half? Half. What is 2/3? Which one's bigger? So you're telling me 2/3 is bigger than a half? And what's our answer? 3/5. 3/5, is it more than a half or less than a half? Nope, that's only multiplication. I need you here. Come on, come on, come on. Bring it back. 3/5, bigger than a half or smaller than a half? All right, which is bigger, 2/3 or 3/5? 2/3. So you're telling me we're taking a number that's big and adding a half to it, and we're getting a number that's smaller?
Yes.
3/5 is smaller than 2/3. This can't possibly be right. It's impossible. So when you forget, do I add them? Do I multiply? What do I do? Right? Try it. Reason yourself through it. Start with small numbers that you know what they mean. Hopefully you know what 2/3 means, right? And reason yourself through it. This can't possibly be it. We need common denominators. Now, that's why we need common denominators, because it's not going to work out. And I'll show you why, okay? So I need numbers that are the same for both of these. So I can divide up thirds into sixths, can I? Yes. Can I divide up halves into sixths?
Yes.
So that'll be nice. Dividing up halves into thirds ain't going to happen. Let me show you. Here's a half. Divide it up into thirds. I instantly get sixths. That doesn't get me thirds. That gets me 2 halves and a half. Or sorry, 2 quarters and a half. I can't do it, right? So I have to go up to the next best thing, sixths. How many sixths are in a half?
3.
3 out of 6, right? That's a half. How many sixths are in 1/3?
You mean 2/3?
No. How many sixths are in 1/3? 2.
2.
How many sixths are in 2/3 then? 4. That check out? So now we're talking apples to apples here. Think of denominators like a unit. We're talking feet and feet. Here before we were talking feet and miles. Okay?
That's scary.
You can't add those up. 4 chickens, if you will, plus 3 chickens. Is it how many chickens? 7 chickens. Chickens is the 6th. It's like a unit. That's why we don't add the 6's up. It's a unit. You don't do 1 chicken plus 2 chicken is 3 chickens. No, you just say 3 chickens, right? 4 6 plus 3 6 is not 7 6 It's 7 6. Okay? How do we add these guys up? No. No. Because that won't tell you anything. It'll give you a decimal, and you won't know what that means. You barely know what fractions mean. Yeah.
This is the bottom of the almost 4.
Mm-hmm. So when we add them up, they're all going to be out of 16,386. That's our common denominator. Right? If I had a quarter plus a 16th, you'd be asking how many 16th are in a quarter, right? If I had this, you'd be saying how much are in a 64 or at a 16th, right? How much are in a fourth, right? So they're all going to be out of this. We had 7 of them, right? No, because that's 1 out of 4. All right, check it out. So we already took care of this guy. How many 16,386 are in 1 out of 4,096? How do we get from here to here? Ah, so there's 4 of them. How do we get from here to here? Multiply by 4. Get from here to here, we multiply by 4. We multiply by 4 again. What do we multiply by? 16, not 8. If you multiply something by 4 and then multiply by 4 again, you multiply by 16. not 8. So 16. How do we get from here to here? Now we multiplied by 4 3 times. What's 4 cubed? It's the same thing as 4 times 2 times 4. I'm sorry, 4 times 8 times 2. 64. $256, right? Because 64 is 3 of them. Times 4 again is 256. You see the pattern? Now we got to add them all up. This is easy. It's all going to be over 16,386. All right, here we go. Which one's going to add up? Parker. 64 and 16, good choice. What's that going to get us? 80. That's a number. 80. Shion, what 2 do you want to add up?
4 and 1.
Okay, so that's a valid strategy. I'm going to try and convince you to do something else, though, okay? Because you're the second person to do this today. They're already really easy to add. So maybe we should take an easy number like 4 and add it with one of our more difficult numbers. So let's take 4. Which one would be nice to add it to? Do you see how these are going to work out nicely? Because it gets us a solid 10. That's going to be 260, which is what I'd weigh if I was a pro wrestler. 1024 and what? Who said it? CJ. 1024 and? Wow, brave. This does work out nicely. If you notice, we're going to get 5,000 something, so I'm just going to write that down. 96 and 24. Let's just do 96 and 4. What's that? Okay? And what's 100 plus 20? 120. And then we have 1 left over, right? Let's add them all up. What's 260 and 80? 340. We get a 1. We get a 6. We get a 4. We get a 5. 5, 6, 4, 1. Or 5, 4, 6, 1. Check out to you. Now, who said it was going to be a third? Isaiah did. Isaiah, does that equal a third? If it does, then you win. Now, here's how we're going to check it. We're not going to type it in our calculator. Here's what we're going to do. If it can be reduced to a third, then we should be able to divide by 3. Is that true or false? Give me a number that's equivalent to a third. A fraction that's equivalent to a third.
2, 6.
Can we divide both numbers by 3? No, so that doesn't work.
So close.
Now, does this equal a third? How are we going to check that? Yeah? That's beautiful. Listen to this. 5, 4, 6, 1, if we times it by 3 and it gets us this number, then it must have been a third, right? Right? Think about it. Right, if I have a third, 1 over 3. Multiply the top by 3. What do we get? The bottom number. It was a third. 2 sixths. 6. 6. Multiply the top by 3, we get 6, right? What is 5, 4, 6, 1 times 3? Well, guess what? It's going to end in a 3. Do you see how I didn't have to get out a calculator? Do you see how I didn't have to think that hard? If I multiply by 3, it's going to end in a 3. Is that a third then? Nope. How close is it? Get out your calculator. Check it. How close is it to a third? How many threes? 0.333 what? Hi, how are you?
333. 272. 305. 62.
All right, so pretty close to 3 repeating, right? Not quite. Why is it close but not quite? How is this not a third? We have 3 equal areas. Doesn't matter how we organize them, right? If I gave you a square like this and I cut it like that, you'd know that that's a third, and that's a third, right? Yeah. So what the heck? I do know what you're saying. I'm not going to tell them what you said and explain it, but you're absolutely right. Why is this not a third? Or is it? And we just goofed. Yeah.
Well, it's going on the street.
Oh, watch the video from earlier today. What?
All the boxes must not be the same size.
How are they not? We divided into quarters. CJ, do you know why this isn't coming out to a third?
I was thinking.
Yeah.
It was an idea.
It's okay, I want to hear your
Okay,
idea.
so you know how we watched that video on how like you cut like a circle and try to make it into like a rectangle that'll never become an actual rectangle?
Yeah.
And it's because they keep getting smaller and smaller that will never actually like be an actual.
How many pieces would we have to cut up the circle into to be a perfect rectangle?
There's, you can't.
Not an actual number, but infinite, right? Infinity. And if it ever did reach infinity, it would be perfect. This guy's going off to infinity.
Yeah.
It never is all the way there. Because if we stop at any point, CJ, that was beautiful. That was beautiful. If we stop at any point, here's what happens. Right? Here's my square. Here it is. Here it is. Here it is. Here it is. If I stop at any point, check it out. Let's color. Red was here. Red is here. Red is here. Red is here. Yellow is here. Yellow is here. Yellow is here. There's always one left over. And that one is the difference between actually a third and almost a third. Is this going to be, is the green, the red, and the yellow going to be more than a third or less than a third in this scenario?
Less. More.
Less than a third, because there's always, to be a third, they'd have to color this guy in, right? So it's always going to be a little bit less. And again, how much less than a third? Well, look, if I do another one, aren't we now closer to a third because there's less left over? So as we continue cutting this up, we're getting closer and closer to a third. There's less and less left over for that error that we have, right? So as we approach infinity, the answer is a third. Now the question is, can you approach infinity and get a third and call that an answer? Is it an answer if we approach infinity, and that's what it is? Here we're approaching infinity, and you wouldn't argue with that. That's a third, that's a third, that's a third, all day, man, right? But as soon as I rearrange it, oh wait, you can approach infinity. If you approach infinity and you get the answer right here, then that's a valid answer. It's valid.
So I was right.
You were absolutely right. That was beautiful. All right, put it away. Oh, last thing. Did you know that if you divide, what's the number? What number did we get? This number right here, 5,461 by 13, you get 420 remainder 1. It almost perfectly divides. I'm on a whole nother level. I'm playing like 5D chess up here, and you guys are down here playing checkers. Yeah. You what? Yeah, it's just not in here. All right, here we go. I gotta go. All right, here we go. C equals 5p plus 215. Relates C, the total cost in dollars of hosting a birthday party at a skating rink. Aw, is there a skating rink around here? Gotcha. Yeah, but then like drugs happened and they had to close it down, right? Story of every small town in America. It relates C to P, where C is the total cost in dollars for hosting the party, and P is the number of people attending. If Nevaeh's parents are willing to spend $300 for a party, how many people can attend? We need to write a compound inequality. So here it is. There's an equality. 5p plus 215 is the total cost, right? What's the top amount of cost that we're allowed to have? So it has to be less than or equal to 300, right? What's the smallest amount of cost we're supposed to have? Now, how do we figure out P? Because right now, remember, this thing right here represents C. That whole thing represents C, right? It's just a big way of writing, right? We don't want to know what C is, right, between 0 and $300 in total cost. We want to know how many people can attend. So we need to get P on its own, right? How do we do that? We do it to both sides and see what happens. So we subtract 215. We get 85. Here we get negative 215. 5 p's left over. We divide by 5, right? Do I need to flip the signs? 85 divided by 5, what's that? Better question, 100 divided by 5. 20, so we're 15 shy. So it's going to be 17. What's 215 divided by 5? Better question, what's 200 divided by 5? 40. What's 15 divided by 5? 43. You don't need calculators. Break it down. So what does it mean? We can invite anywhere between negative 43 people and 17 people? Did we goof?
There's no way
You done goofed.
You didn't switch to the negative.
Nope. We didn't need to. We only divide by a positive.
Yeah. Divide by some.
Ladies and gentlemen, dollars. Any real number, right? You can have fractions. Right? What about people? Our restriction changed. Before we were saying, hey, look, man, this can be anything. C can be anything. Right? But now we're talking about P. And P can't be anything. P's restricted. P's going to have a restriction of this. It's anything between negative 43 and 17. But P also has to be what kind of a number? A whole number. It can be 0. But it can't be a fraction. So automatically that outrules anything over here. So a better way to write this would just be 0. Between 0 and 17 people. You see how that changes things? We went from any number can be C, right? Any price, you name it. It can be a weird fraction, right? You can pay me in pi cents if you want, okay? But P is restricted to the whole numbers. So that negative 43 doesn't make sense. So it's just 0, right? I'm thinking of a number between negative a million and positive a million. But it has to be a positive number. Okay, well, just tell me between 0 and a million then, right? Okay, cool. Know what it means and you won't get confused by this. Okay, and if you're confused now, it's okay, it's new. But if I got you about 50%, that's not bad. The home cleaning company charges $300 to power wash the siding of the house and $10 per each window. Okay, so home cleaning company is $300 flat, right? And then how much per window? $10 for every window. You smell what I'm stepping in? You smell what I'm stepping in?
Of course.
So if there's 0 windows on my house because I don't like sunlight, how much is it going to cost me? $300. What if there's 10 windows? It's going to cost me $400. That makes sense, right? Cool. All right. They say that Power Clean charges $34 per window, but no flat rate. So they just charge $34 per window. So if I have no windows, I get it for free. Now, luckily, no houses have no windows. Otherwise, I could get a lot of good deals here. Okay. How many windows must a house have to make a house cost more to be cleaned by the home cleaning company than the Power Clean? So when is this true, is what we're asking. When is this guy going to cost more? How do we solve it? Well, with 0 windows, he's automatically going to cost more. Right? So the question is, when does that guy become so big that he's actually no longer the biggest? Right? How do we solve a problem like Maria? Come on, it's algebra class. What do you think we're going to do? Get our W's together. What do you want to do? Now what? Does that reduce? Not nicely. Let's estimate. What if it was 300 divided by 25? How many times does 25 go into 100? 4 times. How many times does it go into 300? 12 times. So it's 12-ish, right? So as long as W is less than 12, this will be bigger. Right? After 12, that's going to be a bigger number over here. Now, what's the restriction on W? It has to be a whole number. Cool. Here's your homework. Troy, I had another question that involves your band called Stethoscope. I looked online. There is no band called Stethoscope. It's yours, man. You're going to start a band called Stethoscope. You're going to play bass.
I'm good with that.
I'll play drums today. Or guitar. You play bass or guitar? You play guitar. I have another friend who looks just like you named Troy. He's a bunch of bands, mostly in punk bands. His signature move is jumping on top of the giant ant and then kicking his feet in the air. That's what he does every time. It's kind of my signature move? Mostly twirling sticks and then throwing them in the back. No, we don't have that in here. Did you get one for her? Okay. awful. They break so quickly. Here's what I want.
Probably warmer in here than
First page, all these guys, due tomorrow. First page, all 5 of them. All 5 of them, okay?
That means 6, 7, 8, 9, 10, 11, 12.
We're going to do that the next day. 1 through 5. Yes, ma'am. No, I don't. I don't even know what's wrong with your phone. But... Oh, is it charged?
No, I charged it. Yeah. Can you move it charger?
Did you have anything traumatic happen to your phone between this morning and now?
I know how to reset it.
How old is it?
Take out your SIM card.
Yikes. No.
That's
No.
what I did.
And it fixed your phone to turn it back on?
No, it's not like that. It's because my phone was working.
Right, exactly. So one solution to fix a phone that's not working isn't going to be the same if they don't have the same problems, though. Right? Like, you got gangrene, they got to cut your foot off. That is a valid solution. Now, you got an athlete's foot, they're not going to be like, oh, I had an issue with my foot once. You know what helped? I cut it off, right? Right? Like, I know there's similar problems, but they're not the same.
Like a million times. Hit your home button.
Athlete's foot on my tongue.
They're trying to leave it.
No. I don't know, my clock's broken. I need to fix it.
They have like, yeah.
That's what that.
A million people. Hit your home button. Hit your button.
Are you trying to fix that?
Alright.
What time is it? You put it at 8 on.
I was gonna say, I was gonna hold your home button down. I was like, you don't have to hold it.
These are.
I know it's like the iPhone came out, so that one came out, so now your phone's bugging. This is amazing.
So this has atomic time going on. Once it's set, it will always be
Bro, the camera is so good.
So if you set it for a long time, it's never gonna go back.
You actually allow me to set. You're allowed to select time zones. So atomic time is based on the decay of radioactive isotope, right? And it always behaves at the same rate. And so if you base that rate on moving the hand, right, it's always going to decay at the same rate. The hand's always going to move at the same time. So anytime you turn it off, it's still decaying. So then it just recalculates, figure out how much this case is last on, and boom, we'll figure it out.
Why it's not to tell a lot more time.
Yeah, it's going to take a while.
I just sitting here watching.
Why
Isn't that great?